Hey guys, so today we're going to take a look at how to convert improper fractions to mixed fractions, mixed numbers, and we're going to take a look at how to convert those mixed numbers, those mixed fractions, into improper fractions. So let me give you an example of what I mean. When we have an improper fraction, the top is bigger than the bottom. Usually we see fractions that look like this, where the number on the top, the numerator, is smaller than the number on the bottom, which is the denominator. In an improper fraction, it looks kind of like, if you think about it like a pyramid, it's top heavy, right? Where the biggest portion is on the top. In a typical fraction, like just a regular old fraction, like let's say it was 2 out of 3, the bigger number is on the bottom, the bigger number is the denominator, and the smaller number is the numerator. And so you can see it like a pyramid, like the weightier part is on the bottom. So what we're going to do is we're going to figure out how to convert this into a fraction that makes more sense, a fraction that looks more normal. The reason why we might convert it is so that, well, if we're going to convert it this way to, and let me just, explain what a mixed fraction, mixed number would look like is like, let's say you had 2 and 1 over 3. That looks more normal, right? And so we want to have a fraction that looks weird, like the top is too heavy, and we want to make it look like this, where you're like, okay, I can have a big number, like a whole complete number on this side, and the normal fraction side over here, where it looks just more regular, where the numerator, the top number is smaller than the denominator, the bottom. So let me show you how we do this. When you use a calculator, I'm just gonna move a little over this way. When you use a calculator, it's gonna be a little bit easier. I shouldn't say easier. It might be smoother because you're gonna understand the process. I'm gonna show you very, very basic baby steps how we do this. So our goal is we're gonna try to count to 11 by 4s. Okay, so watch this. And this is where I love having everything super visual, right? So watch 1, 2, 3, 4. There's four dashes so far. 5, 6, 7, 8. Okay, 9, 10, 11. All I did is I counted up to 11 with 4s. Okay, so I can see that I have one complete group here. So I'm going to circle that. There's a complete set of 4. I've got another complete set of 4. So that is 2 wholes, H-O-L-E-S, 2 complete groups. So what I'm going to do is I'm going to take my 2 and I'm going to write a big 2 right here. My bottom number, my denominator, I'm going to keep the same. And I move it over here. The amount that's left, the amount that doesn't equal 4, that is the number that goes right up here on the top. So it looks really chaos right now. This is worth the same as that. If you were to draw it out like you use little pieces of Lego or something, these are worth the same amount. So let me erase all this. So 11 over 4 and 2 3/4. Hang on. Just so that it's super, super clear. So 11 over 4 and 2 3/4. These are worth the exact same amount. It just looks different. The reason why we convert these things is that there's some mathematical equations that are easier if it's like this, but then there's, like when you're looking at things, it would be weird if someone was like, hey, can I have 11 over 4 slices of pie? You'd be like, that makes no sense. Like, it's confusing. Whereas this, you'd be like, oh, you want 2 full pies and 3/4 of another pie. That would make more sense. So let me show you how I did that again. Let's use a different number. So I have 11 over 4. Before I forget, I actually want to show you one that looks kind of normal, right? Let's say we had something like 8 over 4. What would happen is it would just go in evenly, right? Like I'm going to count to 8 by 4. So watch this. 1, 2, 3, 4, 5, 6, 7, 8, right? I have a complete group and I have a complete group, which would make 2, right? My bottom would come over here. It would be the same, but I have no left over. So I would have 0. When you have 0 over top, it's like there's no point in even addressing this. So my answer would just simply be 2. So if ever you get a number where you're like, whoa, it divides in perfectly evenly, that's what happens, and that's why. Okay. So let me show you another one that doesn't divide in perfectly evenly. Let's do something like 13 over, I want to be able to count a little bit. So let's do 13 over 5. So you guys can see this looks kind of weird because the top number, the numerator, is way bigger than the bottom number, the denominator. And we want to make it so that it looks a little bit more readable, a little bit more normal. So I'm going to count to 13 by 5s. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you guys can see this. I've got one complete group of 5. I've got a second complete group of 5. As many complete groups as I have, that's the big number. I'm going to keep my denominator the same, my bottom number the same. It's out of the same chunks is what we divide it into. The amount that's left, whoop, goes on top. Okay, I'm going to show you this one more time. Let's maybe do a number that's a little bit bigger. Let's do, for example, 23 over 2. Okay, this is, get ready. There's lots of lines, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I've got 23 little lines right here. We're going to count up how many complete sets we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11 groups of 2, right? So I was trying to count to 23 by 2. I've got 11. So I'm going to write down a big 11 here. My bottom number, my denominator, stays the same. And I count how many I have left over. I've got 1 left over, so that 1 comes right here. And keep in mind, 23 over 2 is worth the same as 11 and a half. They just look different, okay? It's like saying a half dozen versus 6, right? Like if you may not even know this reference. Let's say the next time you're making an omelet, count your eggs. Let's say you've got 12 eggs. You could either say I have a half dozen, which is dozen is 12, so I have half of 12, or you have 6 eggs, right? So they look the same, they sound different, but they're worth the same. Let me show you how to convert now the other way. So let's say, for example, now I've got 2 and 1 over 3. And maybe I'm trying to do a math equation in which it's easier if I don't have a big number on the side, if I just have what looks to be the fraction part. So let me get another color, and I'll show you how this works. So the first thing I'm going to do is I'm going to multiply the denominator, the bottom number, by the big number. Okay, so 2 times 3 equals 6. And I want you to think of it like a clock. I'm going around in a clockwise motion, okay? So I go 2 times 3 is 6, and then my next one as I go from the big number to this little number, and now I add. So the bottom one is multiply, the top is add. So 2 times 3 is 6, plus the 1, right? So I'm going to write this in. So 6 plus 1 equals 7. So then my 7 is going to come on top, and I'm going to keep the bottom number the same. So 2 1/3 is the same as 7/3. Let's do this again. Let me show you another one. This is really confusing. I really struggle with this stuff. So if you're confused, that makes both of us. All right. So let's do this again. What if I have 3 and 5 over 6? Oh, this is really hard. I gave myself a hard question. So now, oops, let me get my red. So I start kind of like a big clockwise motion. I'm going to do my first number, which is 3 times 6. 3 times 6 is 18, right? 3, 6, 12, 18. Done. So I do multiply is my very first thing that I do. The bottom number, the denominator, always multiplies with this big, huge number that's here. Then I'm going to add the result of that first calculation. So my first calculation is 3 times 8 to make it 6, 3 times 6 to make it 18. Then I add the 5, so 18, 19, 20, 22, 23. So my answer, so hang on, let me just show you. I just went way too fast there. 6 times 3 is 18, right? So 3 times 6 is 18. I take my 18 and I'm going to add it to the 5 on the top, to my numerator, right? Because I multiply first and then I add. I'm not going, what is like 6 times 3 and then what's 3 plus 5? I totally get how you would do that, but no. You take the answer from the first calculation, and then you take that answer and you add the answer to the 5, not the big number, okay? So I went 6 times 3 to get 18. I have to add 18 to 5. So let me just check again. So 18, 19, 20, 22, 23. So 18 plus 5 equals 23. The 23 is going to go on the top. My bottom number, my denominator, is going to stay the same. Let me show you one more example, because this is tricky. So let me show you one with the number 1, because 1 can kind of be confusing. 1 and 7 over 8. It's kind of a weird number, right? 1 and 7 over 8. So let me show you what we do. remember, like I've shown you before, we go in a clockwise motion. And the first thing that we do is that we multiply. So I'm going to go 8 times 1. So let me write here, 8 times 1 equals 8. I take my result of my calculation, and then I add it to the top number. So 8 plus the 7, 8, 9, 10, 11, 12, 13, 14, 15. So my answer is 15. So I'm going to write the 15 is going to go on the top. My 8, my number stays on the bottom. So 1 and 7/8 is the same as 15/8. All right. That's how we convert fractions. Hope that helps. Thanks.